Hey everyone, this is Zoe from Seneca and I've got good news. It's what everyone's been waiting for. Electron shells and orbitals. Let's start. So, the placement of electrons in atoms is complex and there are several levels of organization. Several levels of organization. That's the kind of organization we endorse. So, as per the Bohr model, electrons are arranged in shells. These shells are defined by the principal quantum number, given the symbol n. The lowest energy shell has n equals 1. Other shells have higher energy and a higher n. The higher the n of an electron, the further from the nucleus it orbits. For atoms with more than one electron, shells are split into subshells that have different energy levels, slightly different energies. The difference in energy between subshells is much less than the difference in energy between shells. Subshells? Shells. Subshells? Shells. A shell with a given n will have n subshells. For example, the n equals 3 electron shell has 3 subshells. Subshells are composed of orbitals. Orbitals in the same subshell have the same energy. Each orbital can hold a maximum of 2 electrons. An orbital is a region in space where you are most likely to find an electron. Okay, and bring it all together. Electrons occupy orbitals. An orbital can hold a maximum of 2 electrons, we've already said. A set of orbitals of the same energy is called a subshell. Subshells make up different shells of electrons. Different subshells do not have the same energy. So, one of the fundamental laws of physics is that matter is most stable with the lowest possible energy. When all electrons are in the lowest energy orbit, the atom is said to be in its ground electronic state, or simply ground state. For example, hydrogen has 1 electron and the electron in a hydrogen atom usually moves in the n equals 1 orbit. The orbit in which it has the lowest energy. Electron shells, subshells, orbitals, electrons. So, which of the following are true of orbitals? The answers are: can hold up to 2 electrons, are outside the nucleus, and finally, make up subshells. So, types of orbitals. Orbitals are labelled by letters. The first 3 orbitals are called S, P, and D. Speedy. No, that's not a thing. Okay, an S subshell is made of 1 S orbital, just 1. A P subshell is made of 3 P orbitals. And a D subshell is made of 5 D orbitals. I'll go up into every time. Orbitals of exactly the same energy are called degenerate. You degenerate, you. Okay, so the n equals 1 shell has 1 subshell. It is an S subshell. The n equals 2 shell has 2 subshells. They are S subshell and a P subshell. The n equals 3 shell has 3 subshells. It has an S subshell, a P subshell, and a D subshell. Orbitals are filled from the lowest energy to the highest energy, and the usual energy order goes from S, lowest, to P, higher, to D, even higher. The transition metals are an anomaly, because it was never going to be that easy, was it? The 4S subshell is of a lower energy than the 3D subshell. And so here, the filling order is 3S, 3P, 4S, 3D. Okay, remember that sequence. To determine the electron configuration for any particular atom, we can build the structures in the order of atomic numbers. Each added electron occupies a subshell of the lowest energy available. The diagram here of the Aufbau principle depicts the energy order for atomic orbitals and is useful for deriving ground state electron configurations. So please check out the video if you're listening on the podcast. The big anomaly to remember is with transition metals. Remember this one. the 4s subshell is lower in energy than the 3d subshell. Okay, for atoms with more than one electron, shells are split into subshells that have slightly different energy. And last but not least, how many electrons can one orbital hold? It's 2. Okay, nice. Good job, everyone, and we look forward to seeing you on the next episode. Bye.